Hi, I'm Jeff Banasek with UIC Incorporated. We're here today to go over real quick on how to run an Amine sample. And we're also going to go over the components that it takes to run that sample. UIC delivers our systems as modular components. The system will always consist of a coulometer as a detector, and then either a acidification unit or a furnace unit for producing the CO2 that the coulometer detects. The coulometer works mostly on the principle of an acid-base titration. If you remember any of that from your high school or college chemistry, all we do is we take the CO2 from the sample, bring it into a coulometric cell that contains an amine. The amine and the CO2 combine to form an acid. The coulometer then electrochemically generates a base that titrates the acid back to an endpoint. So what we'll do today is just kind of go through real quick setup of the coulometer and then how to run a sample. First thing we want to do is set up the parameters on the coulometer. The CM5015 coulometer utilizes a 10-inch touchscreen for all of our user input. First thing we're going to set up are the system parameters. First thing we want to select on this screen is change settings. Most amine analyses will be run so we get our results as CO2. The dissolved CO2 in the sample is what we're looking for. So in this case, CO2 is already selected, but we'll press it again anyway to select CO2. Our calculations are mostly going to be based on a volume. We'll be injecting liquid samples into the acidification module in a size somewhere between 0.3 and 0.5 milliliters. So here we'll select volume. The unit of that volume, we'll select milliliters. The percent difference criteria is used to determine the endpoint of the analysis. The default value is 0.1, and we can accept that for right now. The factor is a multiplier used on the results, and in most cases we're going to keep that at 1, and so we'll just select next. The number of readings is the number of readings the coulometer will take to determine the blank, or the minimum number of readings it will take before it applies the percent difference criteria to determine the end of the analysis. In most cases, an amine analysis will take between 10 and 14 minutes. So why don't we just select 10 for right now. The interval is the time between readings. Right now, the default value is 1, and that's generally a good value. The timing method we can either run as an auto endpoint or a fixed number of readings. The auto endpoint will use that percent difference criteria to determine the endpoint analysis, and we're going to go with that. The sampling method is either auto sample or manual. For this method, we use a manual acidification unit, so we'll select manual. The printout format will be standard. And this is just a place where we can put in the instrument ID and the analyst ID. Right now the instrument ID is set as the serial number of the instrument. We'll select both of those values, and we'll be back at the system parameters main screen. Now that we've finished the system parameter setups, we'll go back to the main menu, and we'll do the cell setup. The cell contains a cathode solution and an anode solution, and the two halves of the cell are separated by a glass frit. The glass frit allows electrons to flow through the cell whilst keeping the liquid separated. So the first thing we want to do is select Run Cell Setup. Inside the cell compartment are hookups for the inlet gas, the outlet gas, and the electrodes. The cell's now installed, and with the gas lines hooked up and the electrodes hooked up. We have the cell current switch in the off position. We have the acidification module turned on so that carrier gas flow is running into the cell. We can confirm that by looking for bubbles coming into the cell inlet and that the stir bar is installed and turning. What we want to see here is we're looking at our cell setup number. We want to see a stable value within 10 digits from low to high and the number should be between 2,700 and 4,000. So I look at it right now, I'm seeing a pretty constant value of 3557. So I'm going to accept that value by pressing the next button. What we've established here is the 100% transmittance through the cell. The coulometer uses the light path and a indicator in the cathode solution to determine the endpoint of the analysis and also the percent transmittance through the cell. The higher the percent transmittance, the higher the current. What we'll do now is we'll go to Start Analysis, and we're going to titrate down the cell. You can see when I press Start Analysis, it's verifying that there's an SD card installed in the side of the instrument. The SD card will contain all your data after the analysis, and it is updated and rewritten after each analysis. So no data is lost in case of power outages or any other such occurrences. What we can see now is the cell activity screen. We see that it has a percent T of about 99 to 100% and a cell current of 0. What I'm going to do is I'm going to turn the cell current on. What we'll see is that the cell current will go up to 200 milliamps, and it's going to start titrating the cell. In other words, what we're going to do is we use that current to generate a base that's going to titrate that acid back to an endpoint. When the cell reaches its endpoint, it should be at about 29.5 to 29.6% T, and it'll be blue in color. So I'll just turn on the cell current. And it should take about 5 minutes to titrate down to the endpoint. At that point, we'd let the cell equilibrate for about 30 minutes before we come back and continue our analyses. While we're waiting for the cell to equilibrate, why don't we go over what's happening with the acidification module. The acidification module contains an internal pump that pumps atmospheric air to use as our carrier gas. At first, the air will pump through a pre-scrubber that contains a KOH solution. The KOH solution, of course, removes any atmospheric CO2 from the carrier gas, and we have a nice clean carrier gas that we can use for our analyses. The air pumps into the KOH scrubber, out, and then into the top of the sample column adapter. The sample column adapter also includes a septa for injecting our liquid samples. It also has an acid inlet for our acid pump, and then an outlet where the carrier gas comes out and goes on to our post scrubbers. Part of this column is the sample column adapter, the condenser, and down here the sample flask. The sample flask is in a heated compartment that has a magnetic stirrer also at the bottom. The stirring helps with the sample reaction and helps mix the sample in with the acid solution. Right now we have the heater set at about 45 degrees C, which is a good temperature to run at. It means we don't have to use the condenser to remove any vapor. There are only two interferents for the coulometric detector. That would be sulfur dioxide and hydrogen sulfide. Most amine samples will contain a fair amount of hydrogen sulfide. Therefore, we use an auxiliary scrubber here, which contains a 10% silver nitrate solution, and then we use another post scrubber that contains the same 10% silver nitrate solution. We use the smaller scrubber that's mounted up on the instrument mostly as an indicator to tell us when the main scrubber has been expended. So when we react with our sample, the CO2 and most likely H2S will come off, bubble through the scrubber solution, where we'll see a black precipitate form. That means it's working and removing the hydrogen sulfide. When the gas then goes out of the auxiliary scrubber into the indicating scrubber, and then out and then into the back of the coulometer where the carrier gas enters the cell. For most analyses, 100 milliliter per minute flow rate is appropriate. So we've set our flow meter for that. Now that we've let the cell equilibrate for 30 minutes, we can start with our blank analyses, our standard analyses, and then our sample analyses. First thing we'll do is a blank analysis. We'll press the next button on the screen. And that'll bring us, it'll ask us how many samples we want to run. In general, we'll just run one sample at a time. At the end of each sample, it'll ask us if we want to run another. So we'll select one here and hit next. Here we'll enter our sample names and sample sizes. For a blank, we just enter the word blank. If we use the word blank, it won't ask us for a sample size. We now have the choice to either begin analysis or monitor the cell activity. Since the acidification module has been sealed and the sample flask has been on for quite some time, we really don't need to monitor for any purge. If we were to add a new sample flask, we might want to use the monitor cell activity screen to monitor for purge activity to make sure that any CO2 is run through the system. What we're going to do right now is we're just going to hit begin analysis and run our blank. With begin analysis, we'll inject 5 mLs of acid into the acidification unit and let it run. What the blank is going to determine is the dynamics of the cell, any electronic noise, and possibly any stray CO2 in the carrier gas stream. Since we chose at the beginning an analysis time of 10 readings, this blank will take us about 9 minutes. We take a reading at time 0, so each reading after that will be in a 1-minute interval. So 10 readings will take 9 minutes. The blank is finished running, and we can see that it has placed the results on the screen. We ended up with 6.63 micrograms of CO2 in the blank analysis. In CO2 analysis, anything less than 3.6 micrograms per minute of analysis is a good result. So what we're going to do next is press the next button, and that'll allow us to put in our sample information for our next sample. What we're going to do here is run a sodium carbonate standard at a sample size of about 0.5 milliliters. So our sample name we can just call, in this case, let's call it C1, and enter a sample size of 0.5. Again, we'll get presented with the begin analysis or monitor cell activity screen. Again, since the sample flask has been sealed, we really don't need to check for a purge. So we're just going to go ahead and begin our analysis. What we'll do is we'll press begin analysis and then inject our sample. Follow that with the acid. Remove the syringe. So now the sample and the acid have been both washed down with the center tube down in the sample flask where our reaction will take place. We finished our standard analysis and everything looks good. The reason why we run a standard is just to make sure everything's operating properly with the coulometer. The coulometer itself is calibration free, so we don't need to run multiple standards to establish a calibration curve. We can go right onto our samples. What I'm going to do next is hit the next button and enter in our information for our amine. We'll just call this amine. And again, we're using a 0.5 milliliter sample size. Again, we don't have to monitor cell activity because our sample cell has sample flask has stayed sealed. So we'll hit begin analysis and inject our sample, just as we did with the standard solution. Inject the sample and inject the acid. We can use the acid to flush off anything that might be on the end of the cylinder. We can see the post-scrubbers in black precipitate. That's obviously the hydrogen sulfide from the sample being scrubbed out. So you can see now why we use that larger post-scrubber. So we can see that our sample is finished, and we've ended up with about 35,000 milligrams of CO2 per liter on that sample. If we want to, we can utilize the sample summary button here. here to go back to a summary screen that shows us all the samples we've run. We go back to our results screen. We can either press next to do more samples, or we can press done to go back to the main menu and complete our analysis run. We press done, and we're back to our main menu. That's just a quick synopsis of how to run an amine sample using the UIC CM140 analysis system. Thank you.